Hi, good evening. I'm Dr. Philip McMillan, and today I'm going to be talking about another strange piece of research that has come out. And every time something new is found, I think, why weren't we aware of this before? Because these should be basic, simple questions. Now, what I'll be talking about today is a recent publication looking at, again, class switch between IgG2 and IgG4. I've covered this just recently, but this time they compared the Pfizer vaccine to the mRNA vaccine. And what they found surprised me. And as usual, when you see this kind of research, you then have to go back to the drawing board to say, what does this mean? Why does this happen? So, what I'll do is I'll take you through very quickly a simple set of slides that I was doing. I keep on making reference to these IgG4 principles, but some people don't quite fully understand what it is. So, I'll just make a simple slideshow that I'd taken because of the recent information. So, the reason this is important, this IgG4 question, is because it's not expected. Don't let anyone tell you that this is what they thought was going to happen. Because in truth, IgG4 doesn't make sense in the context of a vaccine where you're trying to stimulate the immune system. So, what they found, or what you find here, is this issue with regards to types of immunoglobulins. As I said, I've covered this many times before, but just for basic science, you have a number of multiple antibodies, and each one of them has different roles. IgM is what's produced in an early infection, first exposure. We don't talk too much about IgG. IgA is usually in mucosal secretions and it can be in the bloodstream. IgE is allergic response. And the IgG is the long lasting antibody. This is what gives you immunity. But it's broken down into four categories: one, two, three, and four. One and three trigger the immune system, two and four less so, but definitely not four. Four is meant to be present to balance the immune system if the immune system is getting too exposed to an antigen like a bee sting. So the beekeepers who are continuously stung, they will have high levels of IgG4 so that their immune system doesn't overreact. But we then started to find this occurring with mRNA vaccines. And so there are a few simple questions that we had to break down. The first was, is this directly related to the spike protein? Because if it was, you'd expect it to occur with natural infection, as well as the other types of vaccines, adenovirus vaccine, viral vector vaccines, say like AstraZeneca or J&J. What the evidence shows is that it doesn't really happen with natural infection or really with the vector vaccines. So we know straight away that it is not purely about the spike protein because you would expect, therefore, it would happen no matter the source of the spike protein. It seems as though what this paper is showing is that you have a higher response. So it's important to note the paper is showing that both the Pfizer and the Moderna trigger IgG4 responses, but it's far higher with Pfizer. Now, I didn't expect that because when you look at the setup, you realize that they are slightly different doses. And we'll come to that in just a second. But just a quick reminder again, in terms of the basics, the viral vector vaccines like AstraZeneca and J&J, when they're injected, they're supposed to go into the cell, into the DNA, get transcribed into RNA, then make spike protein. The advantage in theory with the mRNA is that it doesn't need to go into the nucleus, and as soon as the lipid nanoparticles release them, the mRNA can produce spike protein. And the advantage that they want in the vaccine industry is that they can adjust this far more quickly than any other type of vaccine. And so this is why the big push is coming for mRNA to replace almost as many vaccines as they can. So, as I said before, this doesn't happen with natural infection, doesn't really happen with the vector vaccine. So, we know IgG4 responses are not because purely of the spike protein. So, then we have to examine it a little bit more closely because if it's occurring with mRNA vaccines, I had a specific thought about that, but I'd have to adjust it based on this piece of information. This is the premise with regards to your mRNA technology. You have a lipid nanoparticle, and these are the lipids surrounding it, these little vesicles, and inside you have the mRNA. And this is to protect the body from destroying the mRNA before it gets into the cell. So once it gets into the cell, it will then release these modified RNAs, and then this is the composition of it, and it will then produce spike protein. Okay? Now, before I go any further, it's important to notice a little bit of detail. At this end here is the 5 end. At this end here is the 3 end. And it reads from left to right. Now, here they have a sequence, a codon, which is start, and there's a stop codon at the end, so that it only produces protein from this section. Now, the body has specific rules where it needs something to trigger it to make the protein. So that's the start sequence. It then reads it, produces protein, and then it stops. You must remember this because we're going to come back to this in just a minute. But when it's reading the protein, it will do something like this. This is the ribosome, which makes the protein from mRNA. It's like a zipper. It runs through the ribosome, and popping out at the other end is a sequence of proteins. Okay? And this protein then folds and becomes functional. In this case, if this is the mRNA for the spike protein, it would then produce spike protein. And you have to remember that there's mRNA for every single protein in the body. 5 end would have a start sequence here. The ribosome would start reading along here. It would then produce the protein, and when it comes to the stop end, it would switch off. And that's the premise, what they're using with regards to mRNA. So the question then becomes, if the mRNA vaccines, the spike protein sequence is essentially the same. And when I looked at why it was forming IgG4, my thought was that there was a problem with the degradation of the spike protein, because in both Pfizer and Moderna, they made a slight adjustment, which is different from the infection spike protein and the vector spike protein, where they added 2 proline residues to make it more stable. And my thought is that because they've done this adjustment, it's harder for the immune system to digest this spike protein, and this is what causes it to be more prolonged with mRNA. And this prolonged spike protein issue then causes the immune system to respond in a more tolerant way because it doesn't want to become overactivated. And that's the premise that I've been working on until I've seen this paper. So if they both have the proline sequence in them, and just so that you remember what I'm talking about, if they both have this proline sequence, why would the Pfizer one have higher IgG4 than the Moderna one? So the question then is, what else is different? And this is where we come back to this premise here. So, what it seems as though they have done is that there is a difference with the start part of the mRNA between Pfizer and Moderna. In this case, Pfizer used the start codon for globin um, mRNA. So it's kind of like they copied that from the mRNA that would make pieces for the alpha chain and the beta chain to make hemoglobin. And they did that because it was more stable and they had worked with this before. Conversely, the Moderna used a different start sequence, which is proprietary. I don't know exactly what that is, but it is different from Pfizer. And their aim was to try and get as strong an antibody response as they could. And so they use higher doses, even though they use more mRNA than the Pfizer. It may be because of this characteristic that the Pfizer one lasts longer because the immune system is less likely to degrade it because it sees this start codon as being similar to globin. It's going to be something like that. And this is the problem. We don't fully understand exactly what it is. And at this point, this is a presumption as to why this is occurring. But the differences between the spike protein are so small between Moderna and Pfizer. I have to think that that start sequence is part of the reason why you have higher IgG4 with the Pfizer one. It seems that they used that because they wanted the spike protein to last a bit longer and therefore produce more spike protein. But what we're finding is that it really can last a long time, where it's up to 700 days now. Some people can still circulate spike protein, not everybody, but it does mean that in some people, they really have a problem switching this off. So, as I said, when you look back at the paper here, and I've shown this bit here with regards to the booster vaccination increasing the IgG subclasses, IgG2 to IgG4, and it was comparing the different ones. And clearly, the BNT162b2, which is Pfizer, versus the mRNA 1273, this triggers higher levels of IgG4. Now, as I said, it's an unknown. It wasn't expected, and it's known about since 2022. And I had always thought that the scientific community ignoring this and almost pretending it's no big deal was a mistake, because you should want to investigate everything that you didn't anticipate occurring. And we're talking about 45% and sometimes more of the antibodies are IgG4 after they give a booster dose. So you are then getting a situation where the immune system is not responding to spike protein. And another paper recently published was highlighting that patients who have higher levels of IgG4 are at increased risk of infection, which makes perfect sense. This is a problem, and I genuinely cannot understand how this can have so many unanswered questions, so many unclear issues, and everyone turns a blind eye to it. It's not good science. It's certainly not the standard practice in medicine. Usually, any kind of red flag causes a full reevaluation, but that's up to regulators. I'm just very surprised that at a time where we're still seeing high circulation of COVID, we are understanding that there are abnormal patterns with IgG4. There doesn't seem to be a common sense connection between the two. People have to wait for a peer-reviewed paper to tell them what should be blatantly obvious. We have a problem. And the truth is, we need to find the solutions. This is not going to be easy because, as I said, we have sadly shifted in terms of standard practice in medicine, where there is an important angle that there has to be evidence clearly that there isn't a problem. But these days, it seems to be shifting where if you have a concern, you have to prove it is a problem, meaning that if I'm seeing this here as IgG4, I now have to show that this is going to be a problem long term before they will say this is something that needs to be addressed. That seems the opposite way around, that it should be working. But who am I? Just one more voice that is clearly an annoyance to people who should be looking out for the public health. But that's the latest update with regards to the SANS. I will continue to think about it and look at the implications over time, but just giving you a heads up as to what's going on in the background. And again, final point for those who may not have seen it at the start, this is the most recent paper, July 16th, 2025. So it's come out a bit early in the International Journal of Infectious Diseases. Class switch towards IgG2 and IgG4 is more pronounced in the BNT162b2, which is Pfizer, compared to the mRNA 1273, which is Moderna COVID vaccines. They haven't clearly explained why, and this is certainly something that we need to continue to look at in the near future. Thank you very much for being with me, and have a great evening.